So we're just about ready to start working on a shortcut method for converting degree measure to radian measure, and we'll also have to be able to convert radian measure back to degree measure. And to obtain our shortcut, we first got to do this exercise. We got to first figure out what the radian measure is of 360 degrees, 180 degrees, 90 degrees. These are radian measures that you're going to have to memorize, and you won't have any trouble doing that. You're going to see them so often in the rest of this course. So we're going to go back to the formula to derive these. And so first, 360 degrees. And what I'm going to do is I'm going to take any circle, radius r. I'm just going to call the radius r. I'm not going to assign it a specific value. And so here's my circle of radius r. Now 360 is full circle, right? So the angle we're talking about here is one full rotation through the circle. The circumference is 2 pi r. And the radian measure of 360 degrees is s over r. But for 360, the arc length that corresponds to one full rotation is the circumference. So this is, I'm trying to write c, circumference 2 pi r. And we have to divide by r, and the r will cancel out, right? We got 2 pi r divided by r is just equal to 2 pi radians. So what we see is that 360 degrees is equal to 2 pi radians. And if you get used to labeling angles with radian measure, going full circle is 2 pi radians. Now, what I'm going to do is I'm just going to divide by 2. Because radian measure and degree measure are proportional to each other. So if I take half of 360, that's 180 degrees. The radian measure that I'm going to get is going to be half of 2 pi. If I divide by 2, I get pi radians. And if I divide again to get 90 degrees, so divide by 2 again, and I take pi and divide by 2, I'm going to get pi over 2 radians for 90 degrees. So let's just draw maybe a couple of pictures. Here's a straight angle. That's pi radians. Maybe I'll write the RAD in here. I didn't write that up above. And 90 degrees, which is like 1/4 of a circle, right? Its radian measure is pi over 2 radians. Sometimes people find that a little bit confusing because it looks like 1/4 of a circle. And that's true, it is 1/4 of a circle. But the radian measure is pi over 2, and it's unfortunate, but it really all results from the fact that one full circle is 2 pi radians, not pi, but 2 pi. When we cut that in half, we have half a circle, 180 degrees is pi radians, and half of that, 90 degrees, is pi over 2. The most important relationship here is 180 degrees is equal pi radians. That really you can focus on any one of those three lines, 360, 180, or 90, but I think the simplest relationship is the 180 relationship. And I'm actually going to add that to my card about radian measure. 180 degrees equals pi radians. Because that relationship is going to be the key to our shortcut method for converting back and forth between degree measure and radian measure. So this you want to memorize for sure. That 180 degrees is pi radians. And before we start doing some conversion problems, I just want to say something about notation that we use. When we write degrees, we must write the degree symbol. You can write the degree symbol like the little circle up to the right, or you could write out the word degrees if you want to emphasize that a little bit. The word would be fine too. With radians, no units need to be indicated. Technically, radians do not have units, and you may have heard of this type of thing in a science class. But, in parentheses, it is okay to write the word radians. It's never wrong to do that in my book. And I'm always going to write radians here, because I think if we don't write units, it just gets confusing about what we're even talking about sometimes. So there's our important relationship, 180 degrees equals pi radians. And now in the next video, we'll start some conversions.